All right, we're going to focus on perpendicular lines in this video. So we're going to check our perpendicularity. Perpendicular slopes theorem. So we haven't talked about perpendicular lines yet in this lesson. So here's our theorem. It says if P and Q are both not vertical, so here's P and Q, we can see they're not vertical, then P is perpendicular to Q. So remember, we've seen this symbol before, that upside down T stands for perpendicular, so you can avoid writing out that whole word. So if P and Q are not vertical, then P is perpendicular to Q if and only if the product of their slopes is -1. So remember, product means to multiply. So if the slope of line Q times the slope of line P is -1, then your lines are perpendicular. Another part of the theorem is if one of P and Q is vertical and the other is horizontal. So if you have one vertical line, one horizontal line, then P is perpendicular to Q. That's all we need to say. If you have a completely vertical and a completely horizontal lines identified, you can just say they are perpendicular. You don't need to find their slopes and multiply to see if you get a -1. All right, so example 3, now that we know about our perpendicular slopes theorem, let's check some perpendicularity. So we want to know, are lines J and K perpendicular, and how do we know? So there's kind of a lot going on in this picture. Let's identify where J and K are. So here's J, it's going with this line. Here's K going with this line right here. So we're going to figure out if they are perpendicular, and this work we're going to do is going to show how we know that. So very similar to our parallel equation, we're going to find the slope of both lines. So first, find the slope of line J. So what we do is we take a close look at line J. We want to find two nice clean points that we can identify that J is passing through. So if I follow line J, I can see, here's a good one right there, at 1, +2. And if I keep following, I'm getting another one here at 3, -1. So I'm going to go ahead and make note of that. J passes through, line J passes through, that first ordered pair was 1, 2, and another point that it passes through is 3, -1. All right, so let's find our slope of these lines. So slope formula, y2 minus y1 over x2 minus x1. Here's our labeling our ordered pairs like we did in the last video. So our y2 is -1 minus our y1 is 2 over x2, 3 minus x1 is 1. -1 minus 2 is -3, and 3 minus 1 is 2. So we're getting a slope of -3/2 for line J. Now we want to find the slope of the other line, K. So if we zoom in or just focus on line K, we're looking for two nice points we can use. I can see there's one right here at -3, 2. And then another good one will be right up there at 0, 4. So line K passes through those two ordered pairs. We have a -3, 2, and 0, 4. Anytime you have 2 points of a line, you can always find the slope. So our slope is equal to y2 minus y1. Let me label our points. So y2 is 4 minus y1, 2. x2 minus x1 is 0 minus a negative 3 turns into 0 plus 3. 4 minus 2 is 2 over 0 plus 3 is 3. All right, so now that we have the slopes, how do we know if these lines are perpendicular? Well, that perpendicular slopes theorem just told us that if the products of two lines is -1, then you have perpendicular lines. So let's find the product of our two lines. If we multiply our two slopes, -3/2 times +2/3, do we get -1? So this multiplies straight across, -6 over +6, and we did get a product of -1. So what that means is line J is perpendicular to line K. How do we know? We used our perpendicular slopes theorem, found the slopes of two lines, checked to see if the product equaled -1, and it did.